Hi there, welcome to Susan's 11-Minute Statistics. Today I will be explaining to you how to run an exploratory data analysis in SPSS 15 and interpret the output in 7 to 11 minutes. So let's get right into this. First of all, you might ask yourself, why exploratory data analysis? Well, first of all, it's important to get to know your data. That will make it easier to interpret inferential statistics that come later. It's a good way of quality control for mistakes that you may have made in data entry. If you are performing analyses that require certain distributional assumptions to be fulfilled, this can kind of help you decide whether or not you're fulfilling those assumptions. So is it good enough for Gauss or good enough for Poisson? You can also find outliers that may influence your output or your findings, and it's the first means of kind of getting a picture about missing data and a first way to assess what kind of influence that may have on your results. So let's get right into this. I have my SPSS data file here, and today I'm going to be looking at peak drinks, which was collected in the context of an online survey of 837 college students. We asked them to report the number of drinks they consumed on their heaviest drinking occasion in the past 30 days. So let's go ahead and go into Analyze and start this analysis. First, we go into Descriptive Statistics, and I usually start with Explore. It just gives you the most options of most of the SPSS analyses. And as you see here, I already have it in the dependent list, but you're going to want to go ahead and choose the variable that you want to be looking at and put that into your dependent list by clicking this arrow here. You can also include factors if you're going to be looking at group data analyses like t-tests or ANOVAs. So you could put a categorical variable in there if you want to look at the dependent variable separately by group. Now you're also going to want to click on Statistics to order up the descriptive statistics that will really get you started with your exploratory data analysis. These others are also really helpful once you have a general picture of what your data look like and you want to explore them further. So I'll hit Continue for now and go to Plots. The default in SPSS is actually the stem and leaf graph, but it's pretty old school from back in the days before graphing capabilities were really advanced. So I would recommend clicking on histogram and normality plots with tests. And then you can hit Continue. That way, with both of those, we have the best of both worlds. We have the statistical tests of normality and also the graphs. And then for options, you want to go ahead and exclude cases pairwise in most cases, because otherwise, if a certain case is missing data on one variable that you have in your dependent variable list, it will exclude that case for all other variables as well. So that can really reduce the number of cases in your dependent list for the different variables. So you can go ahead and paste that syntax, and you'll see it shows up in your syntax window. You can highlight that and click the arrow to have it run. And at this point, we get some exploratory data analyses. You can kind of shift around within that by clicking on the sidebar here to indicate what part you want to look at. We'll start up at the top. First of all, we see with the case processing summary, all 837 cases provided data for the analysis, so we had no missing cases here. So that's a good first sign about this data set. The descriptives box is pretty important. It tells you a lot of important information about your data distribution. What I first look at is the mean and the median to see if they're approximately equal. Here you can see they're off by nearly one drink, so that would be our first indication that the data are not normally distributed, in which case these would be equal, but that they might be skewed. Next, I also like to look at, for example, if I'm running a Poisson based analysis, the variance and the mean. So to see if the variance equals the mean, which is the assumption in Poisson analyses. And here you can see the variance is much greater than the mean, which implies that the spread of the data points across the different values of the dependent variable is greater than what we would expect if we were looking at the Poisson distribution. I also like to look at the range of values, so the minimum and maximum, just in case there was some kind of typo in the data entry. So if 999 appeared here, we would assume that none of the college students really had 999 drinks on their heaviest drinking occasion. Not really physically possible. So you can control in a kind of broad way for any major data entry errors. And I would also suggest looking at skewness and kurtosis. Now, the ideal value for skewness would be, and kurtosis, would be 0. And that, if you had a normal distribution, a perfect normal distribution, that's what you would have for both of these values. Really, between -1 and 1 would be close enough or Gauss enough to run normally distributed kinds of analyses. Now, with a skewness above 1, we can assume that there is a positive skewness, so the tail runs off to the positive side of the axis. If we had a negative skewness value below -1, we would assume that the tail is running off in the negative axis direction. And with kurtosis, because we have positive kurtosis here, we can assume that the distribution is pointier than the normal distribution would allow. If it were negative, we would assume it's flatter than the normal distribution would allow. So this is our first signal that we probably have positively skewed, kind of a pointy distribution with a pretty wide data spread across the different values. Next, we look here at the tests of normality. Now, we have two tests. This one you typically use with larger data sets with more cases in them. The Shapiro-Wilk is particularly good with smaller data sets. So if you have below 50 participants in your data set, you want to look at that. These are both pretty non-conservative tests, so you're going to want to look for a value to confirm the normal distribution that would be non-significant. If you have 137 cases, though, a lot of times this will be significant, again, because it's pretty non-conservative. So you can also use a relatively conservative p-value here and say p equals 0.001 would be your alpha level that you would accept. So anything greater than that would be a normal distribution. Here we see obviously very significant tests, so that would imply our data are not normally distributed. And that is confirmed when we look at the histogram. This is probably right here, the zero inflation is probably where the pointiness in our positive kurtosis test is coming from. And you can see the relatively broad data spread that ends with a long tail out to greater values of baseline peak drinks. So it looks like we have some non-drinkers here and then a bunch of drinkers piled up between 0 and 10, and then that kind of tapers off as the values increase. This is confirmed with our normal QQ plot of baseline peak drinks. If we had a normal distribution, we would expect all of our data points to line up neatly across this line that would provide our expected normal distribution. Instead, with the greater values of peak drinks, they tend to pull away from that line, and this is where we can see our deviation from the normal distribution, our skewness. And that is replicated in our detrended normal QQ plot, where we have the deviation from the normal of 0. So if it doesn't deviate from the normal distribution at all these points would kind of be in a nice even cloud right hugging the 0 deviation from normal line here. Obviously, the larger the values, again, the more this distribution pulls away from the expected normal distribution. And this is finally confirmed in our box and whiskers plot, where we see the interquartile range and the median at relatively low values, and we see outliers up here with an extreme outlier, which would be 3 times the interquartile range in SPSS. So obviously a pretty skewed distribution. You would definitely not want to use any Gaussian-based statistics with this distribution without first considering other distributional assumptions like analyses involving, for example, a negative binomial distributional assumption, or perhaps transforming the variable. Thanks for joining me. Hope you join me again soon. Bye-bye.